Hi, this is Vikas here from Trans Water System Private Limited. I have been in the water industry for the past 12 years, and prior to that I used to work as a software engineer in London. And in 2008 I decided to move back to our country and work on water. What do? We convert wastewater to potable quality water. Any wastewater which is available, we convert it to high quality water which can be used for any purpose including drinking. Government has done a wonderful thing in terms of mandating sewage treatment plant. Say any apartment complex, any industry, any layout, they are supposed to have sewage treatment plant. So all the wastewater which is generated needs to be recycled and reused for gardening and flushing. However, we noticed that in spite of having sewage treatment plant, only around 20 or 30% of STP treated water is actually reused for gardening and flushing. The remaining 60 to 70% of water still goes to the drain. We did an estimate that around 180 crore 200 crore liter of water on daily basis after STP treatment is going to the drain. This is equivalent to sending two say Varathur lakes on a monthly basis to the drain every month. So we noticed that there is a huge volume of water which is completely unused and sent to the drain. What does our system do? Our system is a unique 11-stage treatment process where the input is STP treated water and the output is potable quality water. Our system handles all the bacteria, virus, heavy metals and all other contaminants and then converts it to high quality potable water. We also have included IoT to remotely monitor the quality and quantity of water which is going out of the system. Now over time it becomes very necessary for people to know what is the quality of water they are getting and what is the volume of water they are using. For that reason, we have included IoT based systems in our equipments. And we also have done predictive analysis where we are able to do the maintenance proactively with remote data collection in our office call center. So this is what our system does. We make more water from wastewater which is available. So when we notice cities on how they do water management planning, say Bangalore city, how do we do water management planning? We do our water management planning based on what is coming into the city as rain. We see the level of KRS dam and then decide where to distribute water to which segment or where how much volume of water we distribute. However, we notice that how developed countries they manage their water is not based on what is coming into the city as rain. They do their water management planning based on what is going out of the city, which is a predictable volume. They know the population of the city, they know the volume of water which is going out of the city, and they manage their water based on what is going out of the city and not based on what is coming into the city. Because what is coming into the city is mostly unpredictable. What is going out of the city is fairly predictable. So imagine our city, Kaveri water which we get to Bangalore city. It comes from 100 kilometers away. And that water which was previously before Bangalore city was developed was previously used for the agricultural belt. Now the entire agricultural belt depends on groundwater because this water is being supplied to the city. Imagine we recover out of 180 crore liter, we recover 150 crore liter of water. We don't even need the municipal water which is being supplied to the city. Our philosophy in our company, we don't say save water, we say more water. When we go with an attitude of scarcity, we don't find solutions. We have lots of water which is going as waste. We are scarce in terms of groundwater, not on the wastewater. So we say more water, we'll be able to recover any wastewater and convert it to high quality water which can be reused. I believe cities like Bangalore, the only way forward is to recover water and decentralized way of recovering water. These solutions can be implemented tomorrow and we don't need a large infrastructure change required for such implementation. Let's all say more water than save water. Let's adopt technology, recover water, and let's give the water which belongs to riverbed people back to them. Cities can sustain with technology.
We heard how wastewater is being recycled and reused in the city. We also heard how rainwater is being harvested and reused, how groundwater is being augmented and adding to the supply of the city. But mere supply is not enough. Pipe water supply systems tend to leak a lot. It was estimated that about 50% of the pipe network was leaking, and the loss was that high, what we call non-revenue water. So therefore, the city has taken up a system of metering at a retail level where individual households are metered, at a district level, and even at a pumping station level. This metering at bulk and retail helps the city understand and manage revenue losses as well as water losses and reduce it. Also, metering at individual flats and apartments helps customers understand the consumption that they are making with water and to optimize it and become more efficient. Let's learn about demand management now.
First question you asked me about the metering in Bangalore. Many people may not be knowing, the metering started in the year 1909 for the measure consumers of Bangalore. It was started when Vishwanath was the chief engineer, and the meter supply was given to government electrical factory. Since then, metering has been the part and parcel of the BWSSB with respect to accounting of the water that is supplied to the consumers. Currently, there are 1 million connections in Bangalore, comprising of commercial, domestic, non-domestic, and industries. 96% connections are metered. Some 4% where there are some issues with the property and issue with respect to the gated community. There, the flat bill is being issued and the consumption is not metered. That is a very small figure, and over a period of time that will also be taken care, and it will be 100%. So metering, when compared to the other cities in India, it is very progressive, and BWSSB, particularly the Bangalore, has achieved a great deal in that. The second question you asked me about the DMA, district metering area. Bangalore has a very wide, about around 700 square kilometers of the distribution system. Controlling the distribution system is a major challenge and also a task to the engineers of the water board. In order to properly control, we have the service stations and subdivisions, but even that area is also quite big. In a service station, the distribution system will be further broken down into small sectors, what we call as hydraulically discrete areas, comprising of about 2,500 to 3,000 connections, depending on the economic feasibility. The water that is coming into that hydraulic discrete area is measured. The one which goes out is also measured. In that DMA, all the parameters, means the statistics, the number of connections, the people residing, the category of the connection, they'll all be noted and they are recorded. So DMA helps in several ways, mainly with respect to controlling the water to the individual consumers with proper quantity and as well as with the proper pressure, and also helps to plug the leakages. The leakages or the losses, now they are measured in terms of NRW, non-revenue meter, which comprises of both commercial losses and as well as technical losses. Technical losses are directly the leakages. Commercial are the water that is consumed and not billed. Maybe a theft, maybe something else also, the one which is not measured, billed.
Hi, I'm Vivek, Shukla, founder and CEO of Smarter Homes. We essentially work in smart metering for water in high-rise apartment buildings. One of the main reasons that we feel water metering works for apartments is that it helps in two broad objectives. One is everybody starts paying for what they consume because traditionally this is a big problem. Most of the apartments, because they lack water metering infrastructure, almost everybody pays for like a flat fee instead of paying for what they're using. which leads to a huge amount of dissatisfaction amongst the residents, and also not many fights that at least we have come across in the last so many years. After the implementation of metering, people start paying for what they use. So that is the one big benefit. Second is as an indirect benefit, we have seen that in most cases people are able to bring down their consumption by over 35%, and this is proven by the data that we have. Every single apartment where we have implemented water metering, they have been able to save over 35%. So much so in Bangalore South, in one area, I think they have been able to save over 50% water after implementation of metering. Mostly in terms of challenges, most apartments we have not come across resistance in deployment of the meters, because most apartment residents think and they know that metering is going to help. It is the costs which become a deterrent to an extent. But fortunately, with the offering of metering as a service, even that barrier is, so to say, reduced.
A large metropolis like Bangalore, located 920 meters above sea level and dependent on a single source of water from the river Kaveri through pipelines which run 95 kilometers and 300 meters, can be particularly vulnerable to climate change. Both mitigation and adaptation will have to be a necessary strategy for the city to ensure that its huge population, its fabulous economy, and the large number of people dependent on it for livelihoods and employment are able to sustain and manage in a fashion where it does not affect the city's growth or development. Therefore, the city has to look at local resources of water and local ways of managing water as a supplement or as a complement to the pipe water supply from the river. In its arsenal is leak reduction. We saw that the city is focusing on leak reduction in pipes. Demand management. The city has a history of metering and putting in place a tariff system, and is now encouraging entrepreneurs to do the same for flats and apartments, so that every connection in the city is metered and there's a measure of the water being consumed. And with tariffs, perhaps signals can be sent to conserve the water use. The city also cares about its poor, has a pro-poor water policy, making sure that there is universal connection would be an imperative for the city. For the impact of climate change would fall hardest on the poor with the lowest coping mechanism. Demand management is crucial, which is done with metering. Rainwater harvesting would be a way to progress ahead. The city already has bylaws and regulations in place, and there is a flourishing group of plumbers and well diggers who are helping the city actualize the law and regulations on the ground. The citizenry will have to come forward to make sure that it's implemented in larger measures. Lake revival is an engagement which civil society has taken up strongly, both as an advocacy measure by going to courts, but also as a partnership measure with the government in making sure that lakes are revived, either filled with treated wastewater or with rainwater, become ecological and cultural spots, and are helping revive the groundwater. Groundwater has to be better understood. Recharge has to be enhanced. It has to be managed as an aquifer. Laws and regulations have to kick in greater strength and greater measure. And the participation of the well diggers will be crucial to ensure that more and more people recharge the groundwater and use it rationally and sustainably. Wastewater reuse is one of Bangalore's strong points. Treated wastewater is being used for ecological regeneration, for industrial consumption, non-potable consumption, even for potable consumption. Treated wastewater is helping the districts surrounding the city cope with climate change and drought by filling the tanks in their area, the lakes in their area, helping recharge the groundwater and providing water for agriculture purpose. This needs to be monitored carefully so that there are no health risks and environmental risks in the future. Above all, there has to be water literacy in the era of climate change, where each and every citizen becomes aware of the true ecological cost of water. The city will have to look at its river source, the Kaveri, and look at the catchment and the river basin as a whole, and make sure that the integrity of the river is maintained and managed so that the river flows full and always with clean water, and biodiversity in the river is maintained, is enhanced. There is huge amounts of learning coming from history. We have created institutions like the Bangalore Water Supply and Sewerage Board, the Karnataka State Natural Disaster Monitoring Center, Karnataka Tank Conservation and Development Authority, new institutions which are capable of understanding rainfall, of modeling for storm, of managing piped water and wastewater, of managing lakes and tanks in our city. Similarly, we will have to enhance our efforts in groundwater management. Being innovative has been the signature of the city of Bangalore, and that will need to continue. Entrepreneurship will have to be encouraged, incubated, fostered, enhanced, and scaled up so that more entrepreneurs come in the space of water management, water sustainability, and wastewater management and reuse. Finally, a partnership will have to be struck between Samaj, Sarkar, and Bazaar, civil society, the state, and the market, so that in the era of climate change, we are able to cope with the risks that climate change poses to us, and that water and wastewater is managed sustainably in our cities. Therein lies the future for Bangalore.